ഹലോ എവ്രി വൺ, വെൽക്കം ടു വിന്നേഴ്സ് ക്ലാസ് റൂം. ഞാൻ രമ്യ. വിന്നേഴ്സ് ക്ലാസ് റൂം എന്ന ചാനലിലെ ക്ലാസ്സുകൾ നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ഈ ചാനൽ സബ്സ്ക്രൈബ് ചെയ്തതിനെ സപ്പോർട്ട് ചെയ്യുക. അതുപോലെ ഈ ക്ലാസ് നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ലൈക്ക് ചെയ്യാനും ഷെയർ ചെയ്യാനും മറക്കരുത്. Through this video, we are going to discuss 2 mark questions from first chapter, real numbers. This is our first question. Use Euclid's division algorithm to find the HCF of 255 and 867. So we will divide the biggest number by the smallest. Right? Here the bigger is 867 divided by 255. Okay? To make division easier, we will just add 255 plus 255. Okay? Here 0 and 1 is carried. Here 1. So we got 510. That means 255 into 2 is same as 510. You got it? See, we have added 2 times the number. Means we are dividing it by 2. Again let us add 255. We will get 765. Okay, so let us stop this addition here, because if we add again 1 255, the resulting number will be exceeding this one, right? So let us stop by here. So here we have added 255 3 times. When we added it 3 times, we got 765. Okay, now the next step is subtraction. Here 2, here 0, here 1. Next we will divide 255 by 102. Anyways, 102 plus 102, we will get 204. Okay, if we add one more 102 here, what will happen? It will be, the resulting number will be exceeding this 255. So no need to add again 102. Anyways, 2102. What we get? 204. Okay. Then subtract. Here 1, here 5. Next step is dividing this 102 by 51. We know that 51 plus 51 is 102. That means 2 times 51 is 102. So the remainder became 0. Then what will be the HCF? HCF will be this 51. So we got the answer using Euclid's division algorithm. This is our second question. This is really a simple question. Complete the factor tree. See, what will be x? X is equal to 195 into 3, right? See, here the factors of x are 3 and 195. So x will be 195 into 3. And what will be y? Y, the factors of y are 5 and 13. So y is equal to 5 into 13. Okay, so we will get the answers as x is equal to 585 and y is equal to 65. This is our third question. Find the HCF of k, 2k, 3k, 4k, 5k, where k is any positive integer. See, here all the given numbers are a multiple of a single number, right? K is coming commonly in all these numbers, means the highest common factor will be k itself. So the answer is HCF is asked and is k. This is our fourth question. Can two numbers have 15 as their HCF and 175 as their LCM, and give reasons? So HCF is given as 15 and LCM is given as 175, we have to find whether it is possible or not. Okay. Anyways, let us take another simple example. I have chosen 12 and 16 as the given numbers. The HCF of 12 and 16. See, 12 is factorized here, 16 is factorized here. 12 means 2 square into 3, right? 2 square into 3. And 16 means 2 raised to 4. So, HCF, highest common factor, is 2 square. See, 2 square is coming here and here. So, 2 square is the HCF and that is 4. And LCM will take the highest powers of all the factors, right? Highest powers. For 2, the highest power is 2 raised to 4. So, I chose 2 raised to 4. Then 3 is also comes as one of the factors. So, I took that one also. So, 2 raised to 4 into 3 means it is 48. Anyways, HCF of 12 and 16 is 4 and LCM is 48. What is the relation between these two numbers? See, HCF 4 is a factor of this LCM. Understood? We can divide this number 48 by 4 without any remainder. That is the relation. LCM will be a multiple of HCF. LCM will be a multiple of what? HCF. Okay, that is the relation between LCM and HCF. So let us check it here. Let us divide 175 by 15. 175 divided by 15. See here, 25 comes as the remainder, then again one time. See, remainder exists. That means this LCM given in the question is not a multiple of this HCF given in the question. Understood? LCM should always be a multiple of HCF. See, that relationship do not hold here properly. That means this could not happen. It is not possible. That is the answer. This is our fifth question. Find the value of minus 1 raised to n plus minus 1 raised to 2n plus minus 1 raised to 2n plus 1 plus minus 1 raised to 4n plus 2, where n is any positive odd integer. Odd integer. Okay. Anyways, n is odd. Okay. Let us take 3. For an example, n is taken as 3. Then, what is 2n? 2n means 2 into 3. See, I have taken 3 in place of n. Anyways, 3 is odd, no? Then what comes? 2n, what will be 2n? 2 into 3 is 6. Is it odd? No, it is even. Okay. Then 2n plus 1. What is 2n plus 1? 2n is 6 in our example. Plus 1 means 7. That means we will get an odd number. Okay, if n is odd, then 2n plus 1 will be odd. Then 4n plus 2. 4n plus 2. n is taken as 3. Okay, to check whether it is even or odd, we have taken 3 as n. Okay, so 4 into 3. In place of n, I have substituted value 3 plus 2. 4 into 3, 12. 12 plus 2, 14. So, we got an even number. So, this is also an even number. Okay. Anyways, n and 2n plus 1 will be odd and 2n and 4n plus 2 will be even. Okay. Now, here minus 1 is raised to these powers. Okay, we know minus 1 into minus 1 is equal to what? Multiplying two negative numbers means we will get a positive value, and 1 into 1, 1. See, here I have taken two negative ones, right? 2 times, that is minus 1 square is plus 1. What does that mean? If the power of negative 1 is even, then we will get positive 1 as the result. Okay, so where all we get this positive 1? Wherever we get an even power. See, here we will get an even power. Here also we will get an even power. That means these two terms will be positive 1. Okay. So the first term, minus 1 raised to n, let it be there. Then the second term will be positive 1. Then the third term we will find it later. Fourth term also positive 1. Okay. Now let us check what happens if the power of negative 1 is odd. Let us take it as 3. Anyways, we have taken 3 here also, no, to check whether what is the result and all. Anyways, minus 1 into minus 1 into minus 1. 3 times it comes means negative into negative, positive. Positive into negative, answer is negative. 1 into 1 into 1, 1. See, when the power is an odd number, okay, which is given to a negative 1, the resultant is negative 1 itself. See, for these two positions we have odd, right? Odd powers for minus 1. That means this is minus 1 and this is also minus 1. Now what is the result? See, minus 1 plus 1, 0. Minus 1 plus 1, 0. So the final answer is also 0. That is the answer. This is our 6th question. State whether 52.0521 is rational or not. If it is rational, express it in the form of P by Q. What can you say about prime factorization of Q? Okay. Anyways, a rational number can be represented in the form of P by Q, right? The given number is 52.0521. How many decimal points are there? 1, 2, 3, 4. So this can be represented as 520521 divided by how many? 4. See, 4 decimal points means 4 zeros in the denominator. See, numerator and denominators are integers. That means this given number is rational. It is rational. Now we have already expressed in the form of P by Q, where P and Q are integers. And the next part of the question is, what can you say about prime factorization of Q? Here the denominator is notated as Q. This is 10 raised to 4. How many zeros are there? 4 zeros. 10 is 2 into 5. Prime factorization of 10 is 2 into 5. So here Q is 10 raised to 4, and that is 2 into 5 raised to 4, right? 10 is 2 into 5, so 10 raised to 4 is 2 into 5 raised to 4, that is equal to 2 raised to 4 into 5 raised to 4. So this is the prime factorization of Q. Q means here it is 10 raised to 4. This is our 7th question. Given that root 2 is irrational, that is given in the question, and prove that 5 plus 3 root 2 is an irrational number. Okay, we have to prove 5 plus 3 root 2 is irrational. Okay, first let us assume that 5 plus 3 root 2. Assume 5 plus 3 root 2 is rational. Rational means what? We can represent it as P by Q, right? Where P and Q are integers. Now I will write it as this is equal to P by Q because we have assumed that this is rational. Now I am taking this 5 to the next side. So 3 root 2 is equal to P by Q minus 5. See here 5 is positive. When we have taken it to the next side, it will become negative. So like this. Now I am going to take this Q, that means cross multiplication, to make the common denominator. See, this is P minus 5 into Q, 5Q divided by Q. Now what is root 2? Root 2 is equal to, I am going to take this 3 here, okay, shift to the next side of the equal to symbol. Here 3 is multiplied by root 2. When we take it to the next side, it will become divided by. See, numerator part will become denominator part when we shift it to the next side of the equal to symbol. So 3 will come here. Now what we can say, P and Q are integers, means this is rational, right? P and Q are integers means this is rational, but this is not possible. Why? See, root 2 is irrational, that is given in the question, right? But when we have assumed that 5 plus 3 root 2 as a rational number, then we get root 2 is also rational, and which is not possible. So this is also what? This is also irrational. This is the last question of this video. Show that any positive even integer can be written in the form 6q, 6q plus 2, 6q plus 4, where q is an integer. Okay? Any positive even integer can be written in this form, which is given 6q, 6q plus 2, 6q plus 4. Okay, and q is an integer. Let us give the value 0 to q. Assign 0 to q. See, q is an integer, so I am giving q is equal to 0. What will happen here? 6 into 0, that is 0. What will happen here? 6 into 0 plus 2, that is 0 into 2, 0 plus 2, that is 2. Here 6 into 0 plus 4, that is 0 plus 4, that is 4. Now let us give q is equal to 1. Okay, we are going to substitute 1 in all these places. Okay, 6 into 1, that is 6. Here 6 into 1 plus 2, that is 6 plus 2, that is 8. Here it will become 6 into 1 plus 4. 6 plus 4, that is 10. See, if we give different values, what we are getting actually? 0, 2, 4, 6, 8, 10, etc. etc. That means for q is an integer, we can represent the even numbers like this form: 6q, 6q plus 2, 6q plus 4. Okay, hope all of you got the idea. Thank you.